Hello everyone, welcome back to the another session in series of learning C program executions. Now, so this topic is a very important topic as far as your examinations are concerned, theory or practical. This concept is important and this program is very simple. Now let's see what is this program. The program is what? Write a C program to print the result of bitwise operators. Before we step into the program, let's understand about what are bitwise operators. So basically, bitwise operators are bitwise AND, bitwise OR, bitwise XOR, bitwise complement, left shift and right shift. These are what bitwise operators. Now concentrate on this bitwise. These operators are exclusively for bits. Bits are what? Zeros and ones are called as bits. The input which is consisting only zeros and ones is called as binary. So these operators are applicable only on binary. Right. Now look at this program. I did not given this as binary, but compiler of C will translate this into B. That's what the job of compiler, right? Compiler is what? It's a program which converts the user code into machine code. Machine understands only binary. When the moment it identifies as 12, it will not taken as 12. It will be transferring into zeros and ones. Now, let's understand about this. Before we see about this input and 12 and 25, now let's understand what is the output of this operator. When you are working with the bitwise AND, let's see this will be operated in between operands, right? Now the operands are what? Zeros and ones. What are the possibilities we have? If one number is 0, the other number can be 0, because this operation can perform in between two operands. Fine. Now up to here it performs with two operands. Up to here it performs with single operand. For these three operations I need two operands. Let's say my first operand value is 0. Second operand value can be also 0. If it is 0, it can be 1. If it is 1, it can be 0. If it is 1, it can be 1. These are what the possibilities what I can have with the input or with the operand. Now the logic of bitwise AND is what? The output of bitwise AND is 1 when if the corresponding bit of two operands is 1. Two operands is 1. Either bit of an operand is 0, the result of corresponding bits evaluates as 0. This is what the logic of bitwise AND. I'll just simplify for understanding. Logical AND is as simple as your multiplication. Okay, now understand this one with the multiplication. 0 into 0, 0, 0 into 1, 0, 1 into 0, 0, 1 into 1, 1. So when you have two same inputs, then the answer will be 1. So it returns value as 1. Now let's see what is logical or as simple as your addition. That means 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1, 1. This is what your bitwise OR. Now bitwise XOR. Bitwise XOR is for similar inputs it will be 0. For dissimilar inputs it will be 1. It will be 0. 0, 0, 0, 1, 1, 0. Similar inputs. Identical inputs are what? If one is 0, the other one will be 1. If it is 1, it will be 0. For similar, it will be 0. For your dissimilar, it will be 1. Simple. Fine. Now, complement is what? Ulta of the number. That means we won't really make it as ulta. My point of view is what? If A is equal to 12, I am asking. Let's say A is equal to 12. What is the complement of A? That means we were asking the negative sign, negative number of this 12. That means negative binary representation. So A is equal to minus, and this 12 should be this minus 12 should get converted into binary. Will converted into complement. That means we'll calculate the complement. So let's see first of all these three, then we'll go for these three to understand. Fine. Now I'll just erase now what we were discussed, we were discussed about these three operations, right? Now we'll execute a program for these three operations. The other one we'll see after the execution part of this one. Now let's see, I have given here 12 line 25 as my inputs. So a value is what? 12. A value is what? 12. But 12 will be converted into binary. What is the equivalent of binary for 12? You just convert that into binary. So you will be getting what? I am just writing. I can write it as a 4-bit stream, but I am just writing with an 8-bit stream. Okay. So now check whether it is correct or not. You just apply this 2 power 0, 2 power 1, 2 square, 2 cube. 2 cube is 8, 8 plus 4 is 12, and remaining all are 0. So the binary equivalent form of 12 is what? 1100. Fine. Now the first number is what? 12, and the second number we see. Second number is what? 25. Now what is the binary stream of 25? And again I need a 5-bit stream for this, which is 5-bit stream I said, right? So which is 11001. 11001. Check whether it is correct or not. Now we just go with the calculation. 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4. 2 power 4 is 16 plus 8, 24 plus 1, 25, correct? Now, so these are what actually the input what I have given. So this statement is what? Our input. 12 line 25. Now what you wanted to perform? You wanted to perform A or B. What is, A and B. What is A and B? When 0 and 1, it will give you a 0, as simple as multiplication. 0 and 0, 0, 1 and 0, 0, 1 and 1, 1, 0 and 1, 0, 0, 0, 0. Answer is what? 1,000,000. So what is the equivalent of 1,000,000? 2 powers 1, 2 square, 2 cube. Answer is what? 8. So this output value should be 8. Keep in mind this one. The first output is 8. We'll execute this, then you can understand there. Now A or B. What is A or B answer? A or B answer is, now let's see A or B for the same. So A or B, as simple as your addition. 0 plus 1, 1, 0 plus 0, 0, 1 and 0, 1, 1, 1, 1, 1, 0, 1, 1. And this is rest. Now the answer is what? 2 power 0, 2, 1, 2 square, 2 cube, 2 power 4. And the answer is what? Any guess? Answer is what? 29. Correct? 16 plus 8 plus 4 plus 1. Answer is 29. So let's write here. We'll compare with the on screen that. Now A XOR B. Now what is A XOR B? For similar it will be 0. For dissimilar it will be 1. 0 1. Dissimilar 1. 0 0 0. Dissimilar 1. Similar 0. Dissimilar 1. 0 0 0. Now for XOR B, the answer is what? We'll get as 21. Correct? Now let's verify. 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4. 16 plus 4 plus 1, 21. Answer is 21. Let's experiment this. A and B for these input values, first output should be 8, second output 29, third output 21. Now we'll execute this program and we'll check. So now the same input I have given, 12 line 25. Now I'm just compiling this program. Now look at 8, 29 and 21 are output. So these are what? Logical operators. Fine. Now we'll see about the other 3 operands. The other 3 operands are what? Left shift, right shift and complement A. So A complement is what I said, that is what? The negative sign. It is asking for negative sign. Now let's understand about bitwise complement operator. Bitwise complement operator is what? Negation we say. Bitwise complement operator is a unary operator. works on only one operand. That means we use something like this, negation A. It changes 1 into 0, 0 to 1. It is denoted by, let's say, 35. 35 binary value is, I'm just taking 8-bit string, 00010011. So I wanted to calculate negation of A or else negation of 35. What is negation of 35? Just make ones into zeros, zeros into ones. And it is what? 1. It will be 0, 1, 0, 0, 1, 0, 1, 0, 1, 1, 0, 1. So this is what actually negation. So this number can be anything in binary. Let's say this number is what? 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4, 2 power 5, 2 power 6, 2 power 7. So this is what actually, if you calculate all this sum, you will get 220. So generally, when you write this 220, we have a simplified formula. The bitwise complement of 35, negation 35 is what? We will expect actually it may be of minus 36. But instead of minus 36, we will be getting 220. For any integer n, bitwise complement of n will be minus n plus 1. This is what the formula. To understand this, you should have the knowledge of 2's complement. So what is 2's complement? Now I'll just write 2's complement. So if you convert a 0, we'll make the other video for 2's complement. Let's understand about this. So it is what? Minus n plus 1. Fine. So n value is what? 35 plus 1. 35 minus 36. So if you see the value of minus 36, the same value you will be going to get, which is 220 in the decimal. So this is what actually the unary operator or else the negation or else the bitwise complement operator. Now we'll see about left shift and right shift. Now left shift and right shift is what? Now let's understand about left shift. Left shift operator shifts all the bits towards left by certain number of specified bits. The bit positions that I have been vacated by the left shift operator are filled with 0. The symbol of the left shift operator is what? This. Now let's understand how it will be. A is equal to 10. So basically left shift is what? If the value of a variable is left shifted one time, then its value gets doubled. So we will be going to shift the bits towards of left by the corresponding value. Let's say if I write A left shift 1, then A value will be shifted towards of left by 1 bit. If I write A left shift 2, A value will be shifted towards of left side by 2 bits. Now let's see how A value will be shifted by 1. Fine. Now I am just representing A value in binary form to understand. A value I am just taking into 5-bit stream. Okay. Now A value is 10. 10 indicated in binary as 1010. Now, so these are what? Empty cells. Let's say these are what? Zeros. So I have taken 6-bit stream. Actually I need only 4-bit. So it is what? 2 power 0, 2 power 1, 2 square, 2 cube. 2 cube is 8, 2 is 10. So value is A equals to 10. Now let's see how left shift operation will performs. So left shift operation is what? Now A left shift by 1. Take the same bit stream of 5. Now let's see how it will be is, these bits will move towards of left side by 1. That means 0 will be here. Okay, this 1 shifts to this cell. It will be 1. This is 0. And this 1 will be here. This 0 will be here. Fine. Now, the answer is what? Now, look at this. This value will be get truncated. So, this value is what? I am adding this value with this 0. Fine, now calculate the answer. 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4. 16 plus 4, 20. If you do left shift operation by 1 bit to the number 10, then you will get answer as 20. This is what left shift operation. Now, we'll see about right shift operation, how it performs. Fine. Now, I just take out these things. Now we'll see about right shift operation. So I just take the same number, right shift operation, the same number I am taking. What is the number? 1010. The reason for left shift I have taken more bit stream is the value will get double. That's what I have taken more. For this time, I am not taking more bit stream. Right? The reason is what? If the value of a variable is right shifted one time, then its value become half of the original value. That's the reason I am not taking the bit stream of lengthy. Now let's take the same bit strength. Now look at the right shift is what? We will be shifting the bits. I just delete this one, so it will be a confusion again. And now this is what? Original bit strength. Now we'll also delete this one because I wanted to make you to understand more better. Now 1010. Now right shift. Shift the bits into right side. Now that means 1 will be shifted to this box. Okay, 0 will be here, 1 will be here, and this 1 will get discarded from the cell. Now the answer is what? 101. 2 power 0, 2 power 1, 2 square, 4 plus 1 is 5. The right shift of 10 by 1 bit position, a right shift 1 is 5. This is about right shift. This concept is what? Right shift. Yes. So we covered about all the bitwise operators. You can put these conditions over here in the printf statement so that you can demonstrate all the bitwise operators. Thank you all.